Alright guys, so the next part of our unit is inscribed quadrilaterals, and we're going to take the knowledge from inscribed angles today and apply it to do inscribed quadrilaterals too. So if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Okay, so that means angle D and B are supplementary, equal 180, and A and C would be supplementary. So I'll say in circle P to the right, the measure of angle A plus the measure of angle C equals 180. Okay, and I have the measure of angle B and the measure of angle D equals 180. Okay, so let's try to apply this. I'll do 1 and 3. So number 1, we start off with finding angle J, which is supplementary with L. So I will get a calculator out and do 180 minus 92 to find angle J. So that's 88. And angle K is going to be 180 minus 45, which is 135. Okay, so number 3, they only give us arc measures. Okay, so we're going to have to find some of the inscribed angles first before we can find the angles that are supplementary to it. So I know that the inscribed angle D is equal to 1/2 the sum of 39 and 61, right? So I'm going to add 39 and 61 and divide that sum by 2, which is 50. So D is 50 degrees. Okay, so if D is 50, then B, which is across from D, is supplementary. So that would be 130, right? 130 plus 50 equals 180. Okay, and I can see that, I'll change the color here. Angle A is equal to the sum of 61 plus 147, right? That's its arc. So 61 plus 147, and I'll divide that by 2 to get angle A is 104. Okay, and so angle C is supplementary to that. So 104 from 180 is 76. So C is 76, A is 104. Okay. So let's, I'll do number 5 and 7. We're going to have lots of practice on these today. These are important and good for you to practice problem solving, how to solve parts of circles. So number 5 says we're going to solve for x. Okay, and I know that angle V and angle T are supplementary. So this is pretty simple. I'm just going to set 133 and 62 minus 5x equal to 180. Get out my calculator. 133 plus 62 is 195 minus 5x equals 180. If I subtract 195 on both sides, I get negative 5x equals negative 15. So x is 3. Okay, so number 7, they make us work a little bit harder here. I have my inscribed angle H. The endpoints are at G and I. Okay, and its corresponding arc is going to be 50 plus 96. So H is half of the sum of 50 and 96. 50 plus 96 divided by 2. So H is 73. Okay, so I'll set angle H and angle J equal to 180. The other sum is equal to 180. So 73 and 12x minus 25 equals 180. 12x, 73 minus 25 is going to be 48 equals 180. Okay, I'll subtract 48 on both sides. I get 12x equals 132 and divide by 12. I think that's 13, but let's 132. No, it's 11. Divided by 12 is 11. X is 11. Okay. So let's try some of the harder ones. We have number 13 is a central angle intersecting a diameter, right? So I know that angle U is 90, and I actually don't know what we're trying to solve here. I guess we'll probably just be solving for X, right? Same instructions as before. So that means that I can find my inscribed angle S by adding up 90 and 43 and subtracting it from 180, right? Because I have a triangle here. Or just 90 minus 43. So angle S is 47. And that means 9x minus 14. Okay, its inscribed arc is going to be equal to 2 times 47. So 9x minus 14 equals, that's 94. Okay, so I will add 14 to both sides. 9x equals 108. And so that gives me x equals 12. All right, and you guys are going to do number 14. And the one that I skipped down here, number 8. And I'll try some of these harder ones. So if we look at number 17, it says the measure of angle LMP is 5x minus 19 degrees. And the measure of angle LNP is 2x plus 11. Find the measure of PL. Okay. So let's see what we have here. I have angle LMP. That's this one. Is 5x minus 19. And angle LNP has the same endpoints as LMP. Okay, so that means that we can set them equal to each other to find x. So that's what I'm going to do. 5x minus 19 equals 2x plus 11. I'll subtract 2x on both sides and add 19 to both sides. X is 10. Okay, so for finding arc PL, I'll just plug it into the one that I think will be easier to solve, LNP, is going to be 2 times 10 plus 11. So 20 plus 11 is 31, right? Both of these are actually 31 degrees. Okay, so if my inscribed angle is 31, then my arc PL is twice that. So arc PL is 62. Okay, number 18 says the measure of angle P is 4x minus 1. R is 12x minus 27. Find arc PQS. Oh, sorry, dropped my tablet. Didn't go far. All right. So we know angle P and R are supplementary, so that's how I'll start. I'll say 4x minus 1 and 12x minus 27 equals 180. Combine like terms. Add 28 to both sides. And divide by 16. So I don't know what this is. 208 divided by 16 is 13. Okay. So x is 13. And I'm trying to find major arc QPS. Okay, so QPS has endpoints of Q and S. So if we look at that, that is the endpoints of angle R. So if I find angle R and double it, that should be the degree measure of the major arc. So angle R is 12x, 12 times 13, minus 27. 12 times 13 minus 27 is 129. Okay, so my inscribed angle is 129. The major arc is going to be twice that, so I'll say arc QPS is equal to 2 times 129, which is 258 degrees. All right, we did it. Next comes tangents. All right, so let's start tangents. So we'll scroll over to the left here. Okay. A tangent line intersects a circle at exactly one point. Right? And that one point is called the point of tangency. A line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. Okay, so number one, it says determine if AB is tangent to circle P. Okay, so we are going to find out if it's tangent by doing the Pythagorean theorem, because we have a right triangle here, right? It does say a line is tangent if it's perpendicular to a radius. The radius is 8. The tangent line is 15. And then we have the hypotenuse connecting those two, which is 17. So let's see if Pythagorean theorem works out. So I'm going to do 8 squared plus 15 squared equals 17 squared. Okay, 8 squared is 64. 15 squared is 225. and 17 squared is 289. So I'm going to add 225 and 64. So I have 289 equals 289, which is true. So in this case, AB is tangent. I'll write yes. Okay, and you're going to do the same thing with number 2 and figure out if that is tangent. Okay, so for number 3, if JK is tangent to circle L, find X. Okay, so we're going to assume that JK is tangent to circle L, right? And JL would be the radius. Let's find X. So we do the same thing. X is my hypotenuse, so I'll say 7 squared plus 19 squared equals X squared. 7 squared is 49. 19 times 19 is 361. Okay, 361 plus 49 is 410. 410 equals X squared. So X is the square root of 410, 20.248. So I'm just going to say 20.2. Okay, scroll down. I know I kind of started off on the left side, but I'm going to do 6 and 8 now. Okay, so I have in number 6 a diameter MJ, right? So I'm going to say that if LJ is 11, LM is also 11, making that segment 22. Okay, and we're assuming that JK is tangent. So I'm going to say X squared plus 22 squared equals 25 squared. X squared plus 22 squared is 484. Should have known that. And 25 times 25 is 625. So 625 minus 484. Oops, I put a plus. Is 141. X squared equals 141. And X equals the square root of 141. 11.9. So X is 11.9. Okay. So that wasn't too tricky. Number 8, however, is a little bit harder. Let's say that if the radius is X, okay, and LM is also a radius X, I'm going to combine that to be the diameter of 2x, right? 1x plus 1x is 2x. So when I'm plugging in for the Pythagorean theorem, I will say 2x squared plus 7 squared equals 25 squared. Okay, and I'm just going to solve for this 2x squared plus 49 equals 625. I'll subtract 49 on both sides. To get 576. So 2x squared equals 576. All right, and I think that I cannot divide by 2 yet. I do kind of want to say maybe instead of 2x squared, I should have said y the whole time. So that's my mistake. Let's change this to green. Some other variable, and we know to divide by 2 at the end, right? So this is y squared throughout. Okay, because I don't want to divide by 2 and then take the square root. That won't give me the right answer. So if I say y squared equals 576, and I take the square root of 576, I would get y equals 24. Okay, so if the diameter is 24, the radius, x, is equal to half that, which is 12. If I had divided 576 by 2, I don't think this would have worked out. So if I said 576 divided by 2, and then took the square root of that, okay, that wouldn't have given me the right answer. So I think that was a good call for me changing the variable, and sorry for the confusion there. Okay. Number 9, we are given x and 20, and the hypotenuse is something plus 10, right? Because I don't know that one. So I'm going to say, well, if this LJ is 10, L to the edge of the circle here, or sorry, if this LJ is x, L to the edge of the circle here is also x. So I'm going to say this is x plus 10. All right, and let's see what happens here. If we plug into Pythagorean's theorem, I think this is going to be a little bit messy, but not too hard for you to handle, right? You've done algebra, so this we can do. I'm going to say x squared plus 20 squared equals x plus 10 squared. Okay. X squared plus, well, 20 times 20 is 400 equals x plus 10 squared. And I'm going to multiply those binomials. X plus 10 squared means x plus 10 times x plus 10, right? X times x is x squared. X times 10 is 10x. 10 times x is 10x. And 10 times 10 is 100. Okay, and we combine these to be 20x. So I'll set this equal to x squared plus 20x plus 100. Okay, so now we're going to simplify this. Let's subtract x squared. Whoa, sorry, I don't know what happened. We'll subtract x squared on both sides. Right, that makes my x squareds cancel, which I could have done anyway. Because if I have the same thing on both sides, I can just cancel them out. I'll also subtract 100 on both sides. So now I'm left with 20x on the right and 300 on the left. 300 divided by 20 is the same thing as 30 divided by 2. So that would give me x equals 15. All right, so that's not too bad. A little confusing, and you could probably use a few more of those. And I'm sorry, I think I did the only one. So I'll try to get some more practice. All right, so we have more tangent line properties. The next one says, if two segments from the same external point are tangent to a circle, then they're congruent. So basically, if my external point, AB, connects my tangent line, let me draw in green, my tangent line AB, and my tangent line CB, okay, and they intersect at point B, then those tangent lines have to be congruent. So AB is congruent to CB. Okay, the second one says, If a polygon is circumscribed around a circle, then all sides are tangent. So that means AB is tangent to circle P, BC is tangent to circle P, and AC is tangent to circle P. Okay, so let's apply some of these. Number 10 says, find each measure or value. Assume that the segments that appear to be tangent are tangent. So we have number 10 looks just like the first property. Two segments from the same external point are tangent to a circle. So here's my external point that they share, point B. And I have tangent line BA, tangent line BC. Okay, so I'm going to assume that those two tangent lines are equal and solve for x. So that means 8x minus 19 equals 5x plus 23. I'll subtract 5x on both sides and add 19 to both sides. 20, so that's 42. And if I divide by 3, 42 divided by 3 is 14. X is 14. Okay, you guys should be able to do number 11, no problem. I'll do 12 and 14. So it looks like number 12, we have a shared external point, S, two congruent tangent lines, SV, ST, and SU are congruent. So ST is congruent to SU. I could solve for x and plug it into Pythagorean's theorem to find SV. So here we go. I have 10x minus 41 equals 4x plus 7. I'll subtract 4x to both sides, add 41 to both sides. That's 48. And x equals 8. Okay, so if x is 8, then I could say 4 times 8 is 32 plus 7 is 39, right? And this one should also be 39. And so if my radius is 17, my right angle is at the tangent point T, okay, I can find SV by using Pythagorean's theorem. So 17 squared plus 39 squared equals C squared. So 17 times 17 is 289. 39 squared is 1,521. I'll add 289, 1,810. Okay, so that gives me C equals the square root of that, 42.54. So I'll just say 42.5. Okay, so SV, I'll say SV instead of C, is 42.5. All right, we're almost there. Okay, so let's see what we got here. If a polygon is circumscribed around a circle, then all sides are tangent. So here is my shared external point, right? I'm using both theorems here. So I have my shared external point R, meaning that this line segment is 27.1 and this line segment is 27.1. So I think I'm going to write it down because I think we can use that to solve for our missing pieces. So I'm going to do 52.5, that whole side SR, and subtract 27.1. Which is 25.4. Okay, so maybe not yellow, but I'll say this line is 25.4. So this one is also 25.4. Okay, and we're almost done. We're going to have to, hopefully you can see, subtract 23 from 37.5. To get 14.5 for this point here, right? Because I know that this is 23. So this one is, I'll change the color. This is 14.5. So this part here is also 14.5. Okay. So now I have all my side lengths. PQ, they gave us is 37.5. Okay, QR is 14.5 plus 27.1. All right. SR, they gave us 52.5. Okay. And PS, they did not give us. We're going to have to add 25.4 and 23. And that brought us all around the quadrilateral. So I'll add all those things. 37.5, 14.5, 27.1, 52.5, 25.4, and 23. Okay, so the perimeter of PQRS is 180. All right, so you guys are going to do all the ones that I skipped. And we will review it tomorrow. Okay, good luck. Thank you.